As of 2021, Americans James Lovell, Fred Hayes, John Swigert are the three people who have traveled furthest from Earth during the Apollo 13 mission. When they flew behind the moon, they were 400,171 kilometers, 248,655 miles, from the surface of the Earth. Light takes 1.335 seconds to cover that distance. Many of us have certainly fantasized about going into the stars, or at least exploring the solar system. The feasibility of doing that safely is still slightly out of reach, but we are certainly striding towards further and further forays away from the comfort and safety of our own planet. Could we reach other planets? Very likely. How about other stars? Maybe one day. What about the end of the universe? There is actually a way that doesn't require any science fiction solutions, or at least nothing beyond the physics we know. Let's look at the technologies we need to go further deep into space. If we want to go to the moon, Mars, and beyond. If our goal is to explore the solar system, we have a lot of the technology already. There are powerful rockets already in use, and crewed vehicles are being designed to carry humans back to the moon and beyond, but there are many concerns. The further we are away from Earth, the higher dose of cosmic radiation we receive. Our planet's strong magnetic field shields from a good chunk of that. What's protecting you when you're going into deep space? Researchers have actually tested a solution. Fungi discovered in Chernobyl survives on radiation, and this could one day be used as a living shielding system on spacecraft and human habitats. Journeys also would take many months, if not years, and there is a lot of talks of one-way trips. In general, everywhere else in the solar system is an extremely dangerous environment that can easily kill us. While we might reach it, this doesn't mean we can thrive there. And remember that most medical interventions in space might be extremely difficult to perform. There's also the possibility that alien life exists somewhere nearby, so we need to discuss how our presence there might endanger the potential organisms living beyond Earth. If we want to go to the deep stars. If you think that all the challenges of local space travel can be solved, let's believe they can for now. Maybe you want to turn your attention towards the stars. Could humanity travel to another star system? Humanity, maybe. A single human, not really. Let's take Proxima Centauri, the closest star to the Sun. At the speed of light, it takes just over 4 years to get there. If we were to achieve the speed of the fastest spacecraft ever, NASA's Parker Solar Probe and its closest approach to the Sun, it would take almost 8,400 years to get there. And that's without slowing down to stop it. There are proposals to send robotic explorations there. Miniature crafts might get there in just a few decades, and larger nuclear-powered ones could do the journey in a few hundred years. Those are very exciting, but they are not suitable for humans. And even if they were, that's still beyond the human lifespan. A solution to this might be a generational ship. The first generation would leave our planet and their descendants would reach the star. Obviously, we should wonder why anyone would start this journey. But it's equally important to discuss the ethical and psychological state that the in-between generations, these interstellar middle children, might be in. Would they be interested in keep going towards something they would never see? Now, what about getting close to the speed of light? Can we make it faster? And could we reach nearby galaxies and beyond too? Well, at least in principle, yes. What you would need is a relativistic rocket. This would allow a handful of humans to travel incredible distances, and it doesn't require anything beyond our current understanding of physics. You need a rocket that is accelerated by about 9.81 meters per second squared. That's the average Earth normal pull, so people in the spacecraft would feel like they are simply standing on the surface of our planet. Such an acceleration would quickly bring the spacecraft to relativistic speed. Getting close to the speed of light, the passage of time on the spacecraft will slow down. This quirk of physics was popularized in the twin paradox, and in this relativistic rocket, you are the twin that flies away and doesn't age. The clock outside would still be ticking. So, you could reach Proxima Centauri in 4.3 years, but on board it would feel like 3.6 years. If you instead wanted to go Vega, 27 light years away, on board, it would feel like 6.6. The further you go, the closer you'd be to the speed of light, and the slower time will pass. Now, suppose we can do a journey to the edge of the universe. So you could get to the center of the Milky Way in 20 years or to the Andromeda Galaxy, located over 2 million light years away, in a merely 28. Obviously, 2 million years would have passed on Earth. But there is a limit to how far we could go? Yes. The universe is expanding, and this expansion is accelerated. The space between galaxies, unless they are very close, gets wider and wider with every passing second. And the further two things are in the universe, the faster they appear to recede from each other. There are galaxies that we see in the sky that we can no longer reach because the only way to do so would be to move faster than the speed of light to make up for the accelerated expansion of the universe. This border is called the cosmological horizon, and its exact size depends on the correct cosmological formula to describe the universe, which is currently a work in progress. Still, it could be possible to reach this boundary in a few decades. An empty, cold, and unmarked border in the universe. So why don't we have such a rocket? Well, fuel is the reason. To sustain such a constant acceleration requires a huge amount of fuel. Even imagining an extremely efficient reaction that we don't have, you ought to carry a lot of fuel with you. Like a planet-size worth of fuel. The moral of the story is that space travel, as far we currently understand it, is complicated. We have so many challenges to deal with, whether they are technical, physical, physiological, psychological, and ethical. How we approach them could make all the difference. So, what do you think about it? You can give your comments below. And consider subscribing.